project to create an AEV which would be energy efficient and be able to run on a track to a station, pause at the station, then continue at a slower speed along the track to the docking area where it would pick up a caboose and then go back to the station at the slower speed. To do this, we created the AEV we nicknamed the Batwing.
I'm Greg Mansberger, and I was the Supreme Master SolidWorks designer. My job was all of the SolidWorks building of models and the AEVs, and I worked on the energy analysis program for MATLAB.
I'm Ashley Crum, and I am the final touch specialist. It was my responsibility to write most of the documents for the AEV, and I also served as the final quality check.
I'm Julie Brested. I'm the team secretary. I organized the project notebook, and I made the project schedule.
I'm Brent Bender. My title was Captain America. I was in charge of transporting the AEV to and from class each day. I was the main builder in building the AEV each day, and I was also the main coder for the Arduino program for our AEV Batwing.
This is an overview of the AEV initial design concept. Initially, each team member designed their own AEV with a 3-view isometric drawing. We noticed that there were similar characteristics between each person's AEV design. They all had a T-shaped base, 2 propellers at the back of the AEV in the pusher position. So what we decided to do was combine Grant's AEV design and Greg's AEV design into one AEV design. Grant's design initially was a lot more balanced than any of the other designs, and Greg's had aerodynamic components. So with both of them combined, we would have an aerodynamic AEV and a balanced AEV.
Here are the initial sketches for our AEV. The hand-drawn design for the AEV. And here are the SolidWorks CAD models for the AEV, the early and the improved design, followed by the final design.
We had 3 major problems during our experimentation method. One was the balance of the AEV. It was a little off-kiltered, and there's a lot of weight on the back wheel, so it would jump off the track occasionally.
We fixed the balance issue by taking each portion of the AEV, mostly just the battery and Arduino, and we moved them around on the AEV until we found a good center of mass to work with.
Our second problem occurred while we were testing the AEV on the track. Whenever we ran the program, it would overshoot the tape and not make any of the points where we had to stop.
We remedied this problem by using a reverse function with the propellers. The propellers would spin backwards, creating force to make the AEV go in reverse, thus stopping it exactly where we needed it to.
Our final problem was after we fixed the program and got to stop where we needed to, the AEV would get stuck in the dip that started to form over time.
We fixed the problem of getting stuck by increasing the power on the motors. An increase in power allowed us to shoot up the hill and get to the goal.
This is a successful run that we had. It was able to stop at the station and was able to bring the caboose all the way back to the station on their return trip.
Yeah, it's good.
Can this be counted as an actual run if this?
You guys are on this side too. It's too inconsistent.
Oh man.
Once we got down the initial Arduino code, trial and error became our best friend. We'd make changes to the code, run the AEV, figure out what points needed to be changed, and then we would go back and make changes.
If given the chance to do this project again, we would make an AEV program that was more efficient for the AEV when it ran on the track. Also, we would try to build an AEV with lighter material so that it wouldn't take as much
project, the team now has a greater understanding of what it means like to be an engineer. We now know the teamwork that must be put into the project to make it successful. We know the time that must be put in to make it successful. And we've also found out that it takes a lot of trial and error to come up with the best possible idea for the AEV.